So hi, everybody, and welcome to this session of the use cases with datalift number 6. We have here Thiago, Rigo, and Bora, Kaplan from GetYourGuide. I would like to welcome all of you and kindly ask all of you to stay muted. If you have questions during this talk, please write them in the chat. And then I will read them after the Thiago and Bora have given their talk, and then we can have a nice discussion all together. And I would like to remind all of you that this session is recorded and with permission later will be put on YouTube. And I encourage all of you to please help us reach out a broader audience by just posting about this event on social media. And you can use the hashtag datalift. Okay, then now I give the virtual stage to Thiago and Bora. Please go ahead.
Yeah, I think he's having some issues now.
Okay.
He's just gonna come back in a second.
Yeah.
But yeah, most likely I'll just share it instead if he's still facing issues.
Yeah, I also have your slides, so I can also share, but I think it's easier if you share yourself.
Yeah. Right, guys. Yeah, sorry for that. I guess let's just wait like a few more seconds until he's back up, and then we can do it.
Yes. So meanwhile, I will also write about this data lift summit that will be in summer. I will put it in the chat. So if you guys are interested, you can register for the datalift summit in June. It will be in person in Berlin. Oh, Bora is back.
Yeah, I can hear you now. Sorry about that.
Okay, perfect. No worries. So yeah, please go ahead, Thiago and Bora. I give you the virtual stage.
Okay, then I can start.
Yeah.
So hello everyone, welcome to our talk. So today we're going to talk about events tracking at GetYourGuide, and how we started tracking, why are we tracking events, and how we're currently doing it, and what are the next steps for us. So let's get started. Quick introduction, I'm Bora. I work with Thiago at data engineering team at GetYourGuide. I've been at GetYourGuide for 5 months now, and as a data engineer, I like working with streaming systems and building all kinds of tooling around data applications. Would you like to introduce yourself, Thiago?
Yeah, thanks. So hi, everyone. My name is Thiago. I'm an engineering manager at GetYourGuide. I've been with the company for 4 years now, and I've been working with data engineering for the past 6, and I think in software engineering for about 10 years now.
Great. Also, quick introduction about the company. We are essentially one of the largest marketplaces where you can book tours and activities all around the world. And it's simply our goal to provide incredible experiences and unforgettable experiences for people. And we do that by providing more than 60,000 tours or activities available in more than 150 countries. And we have more than 170 traveler nationalities using our platform. And we are a strong global team of 650 people. So why are we tracking events? To be able to provide people incredible experiences, we have to know what it means for them. So we have to learn about them. And to be able to do that, we cannot just rely on our services databases, because it's not going to track every single action a user takes. And we cannot also simply use server logs. It's going to be cumbersome, and it's not going to be enough either. So we need specifically built pipelines and services for this purpose. And Thiago is going to explain how we used to do that in the past.
Yeah. So great. Yeah, now that we understand why we can't just use weblogs, we actually can jump into our journey and how we actually started from the very beginning, just parsing logs as well. So back in 2016, we started with this project in the company, where we wanted to have more data, more than we simply just have on the database, right? Because if you think about the database, it's just something that the services are writing when a user performs some important action, let's say in our case, booking something. But we wanted to have actually more granular information and understand when the user is navigating to specific pages and conducting specific actions, such as clicking on a specific button and things like that. So the setup we had before wasn't really good enough. That's why we started back in 2016 with this approach. So back then we started with a very, very simple approach. We had all the web server logs being streamed to our data lake. So this is something that the infrastructure team set up for us. And we had all the server logs written as tab separated files to our data lake. And on top, so this was already enough for us to capture a basic understanding of user behavior on the website. And then we also had this other API called Ping, which was essentially receiving events data from the mobile apps and then writing this JSON to the data lake. So to give you one example, what we call an event, if you go to the app and you open the app, it's going to trigger an event called app open. If you navigate to a specific page, for instance, like a discovery view, that would trigger also another event. And all of these events were sent to Ping, this API, and everything was written as JSON to the data lake. So there's a few benefits to this solution. First, it's super, super simple. There's not much infrastructure to maintain. And it allowed us to capture richer data other than just the database. So we're able to look at data from the website coming from the web server, as well as apps data. It did have, however, a few shortcomings. So web server logs data is okay, but it really isn't rich enough. And it's also quite fragile. Let's say you have analyses that are based on like regular expressions checking the URLs. If the URLs change, your analyses are also affected. Also, the apps data that we collected wasn't really high quality. This service simply received the JSON payload and it would just write it directly without actually checking anything. So sometimes we would find out only when we wanted to analyze the data that the quality was really, really poor and the schemas didn't match, so it was like a mess. And then lastly, another thing we wanted to do, I wanted to do some basic enrichment directly on the API, and that wasn't really possible because this service wasn't maintained anymore. So to give you one idea, we wanted to add geolocation information, but we couldn't really do that because it requires storing the IP address, which because of GDPR, we can't really do that, right? So we couldn't just do that downstream. We had to do in the server. So if we go to the next slide, I'll tell you how in 2018, we actually started tackling these issues and came up with the V2 of this architecture. For this architecture, we started looking at events only, and then we also developed our new API and also changed the data format we're using. So how did that look like? We introduced 3 new components. So we introduced collector, which is an API we created, essentially replacing Ping. This API was used, it's still used to receive events data from the apps. So, app open or discovery view and things like that. But now it actually validates the data against the Thrift definition. And then with this Thrift definition, we can check the types. Once that is checked, we make sure that only correct data flows downstream. And then we also created this other component called Analytics Quickline, which is essentially reading all this Thrift binary data from Kafka and then write it out as Parquet. So Parquet is way, way more efficient to work with in the data lake. So if you remember the previous solution, we had JSON and TSV. So that wasn't very performant and it wasn't very rich. But now with Parquet, it's much, much better. So a few benefits of this solution. First, we have strong schema definition, which solves so we ensure that we only have quality data downstream. Whatever is tracked, we make sure that the types are correct. Since we now own this API, like collector, we're able to do some kind of basic enrichment on the API directly. So right now we're actually doing this enrichment with the geolocation, which is great for us. And just in general, if you see here, we're not using logs anymore. So it's much, much more stable and it's like a lot richer. So we can do a lot more things with this data. A few shortcomings. What we realized is at this point, we had an explosion in the number of event types tracked. So we went from 30 different event types to 250 we have right now. And that means we became a bottleneck since we are the teams controlling the schema definitions. So if you have 20 plus teams constantly making changes to your events, you quite quickly become a bottleneck because every single change has to go through you. Another bad side effect we saw was that this created like low ownership with the producer teams regarding the quality of their data. If there is some data that is wrong, like we are usually the first teams to be contacted, which also doesn't scale as the organization grows. And then lastly, like due to how we were using Thrift, all the properties were marked as optional. So here we can already ensure the correct schema type, but we had like another problem, which is a lot of the time, not all properties are being sent on the event payload, and we didn't really have a good way of monitoring that. So these are a few shortcomings on this solution. I'll hand it over back to Bora to tell you how we're fixing those now.
Thank you, Thiago. So as you can see, we have a few shortcomings from the previous versions, and with all the learnings about we had all around these years, we built new version using OpenAPI and async API, which means team can own their own schemas and have decentralized schemas all around the pipeline. And we can also do real-time enrichment. And we do that by introducing two new components. With this architecture here, we still have collector and quickline from the previous architecture, but now we have schema API registry, which contains all our OpenAPI and async API definitions. We also have analytics enrichment pipeline, which is multiple streaming applications that we're going to mention later. So when a new event comes to collector, when a user, for example, open our website and basically picks a tour to see, we're going to get a collector payload containing analytical data about that user action. And it's going to be provided in JSON as an HTTP payload. And also we're going to get HTTP headers and, for example, geolocation metadata directly from Istio ingress layer. It's going to be coming from a Kafka topic. And collector is also going to validate the incoming analytical data using the new OpenAPI schemas coming from schema API registry. So both of these data are going to be pushed to Kafka topics, and then both of them are going to be picked by analytics enrichment pipeline. And it's going to use these data and combine these two to enrich the data on the go, basically. So we have real-time enrichment available, which is going to have more data than previously available before. And then we're going to basically just push these data to targeted Kafka topics for every single event. So from here, we have enriched data. People can just directly consume these Kafka topics, and they can instantly access to enriched data and get value from it. And of course, we have schema validations and checks all around these steps. So we have strong property validations. And of course, quickline is going to consume the topics again and write as Parquet to our data lake. So with this approach, we have from the get-go, using OpenAPI and async API provides us richer property validations. On top of syntactic validations, we now have semantic validations as well. So we have more control on our data. And you can see we have real-time enrichment done by analytics enrichment pipeline here. So we have better data quality essentially, and more metadata available for us. And we are using JSON instead of Thrift with this version because it's a company standard that we use internally, and we wanted to stick to the standard as well. So we're using JSON, which is nice. So we can basically read our payloads easily. And we have better monitoring because everything is more decentralized and people can own their own schemas and they can get alerted if there's any problem about that. And we also can control our systems better independently. And as I mentioned before, teams are more independent now because teams are going to have to create their own schemas in their own repositories, and they're going to basically publish to the schema API registry themselves. And we're going to consume these published schemas and basically run the validations checks that way. As you can see, we have some shortcomings as well. We introduced a few more components and it's got a bit more complex. We have to introduce schema API registry to contain all our new schemas, and we have to provide toolings around this. For example, people need to publish their schemas, people need to validate if their schemas are correct or not. And we also have to run some backwards compatibility changes to see if the new versions of the schemas are compatible, essentially. So As you can see, this means a bit more complexity and more components to monitor, more code to maintain. And basically, these are the shortcomings of this current version. And this is a quick summary of the previous iterations. We started really simple. We were just reading some log data, which was enough to get us started, but it wasn't rich enough and we couldn't control schemas. So we moved on to the Thrift version. We had some sort of schema definitions now, but as event numbers are growing quickly, our team became a bottleneck. And now with this new version, we have OpenAPI and async API schema definitions, which means teams can own their own schema definitions. And we have richer property validations, and we can do real-time enrichment on the go, essentially, which comes with the cost of higher complexity and more tooling. So what are the next steps for us? I mean, this is an ongoing project, so we're currently going through a migration phase, and we want to ensure this migration phase goes as smooth as possible, and we want to provide documentations for producers and consumers, so they know exactly what to do and what are the timelines for this project. We want to reduce complexity and gray areas of some tools. For example, OpenAPI and async API are great tools, but sometimes they can be a bit like a black box. And we want to reduce the complexity and know and basically have better understanding about these tools. And we want to provide tooling for data discoverability, which is a really important topic for us because we are collecting all these events and basically providing a good platform for people to use them. But if they cannot discover the data, if they don't even know these kind of data exist, it's not going to bring a lot of value. So we want to make sure people can actually use these data and they know how to essentially reach the data and use it. And of course, we want to ensure data quality after all these migrations are done. And we're going to have some automated anomaly detection as well. So we will make sure that the data is top-notch there. And with this, our presentation is over. So thank you for listening. If you thought these topics are kind of interesting, you can check our careers page because we're hiring. And you can reach out to me or Thiago directly as well, so we can have a chat about it. Thank you again for listening.
Thank you, Thiago and Bora, for the interesting talk. I would like to encourage everybody to write the questions in the chat. We have one question now from Yvonne. The question is, was each architecture upgrade handled as a parallel greenfield project? And if so, how long did the implementation take roughly?
Yeah, maybe I can start, Bora, if you want to add on top. So yeah, that's a good question. And yes, every time we had like one of those migrations, so as Bora mentioned, the third iteration is something that we're currently right in the middle of this transition right now. But to answer your question, like in each time we had this migration, we completely had a separate different pipeline running production, and events were being sent to both places until we could validate the data and then finally switch. So as you can imagine, this is actually like quite time consuming because we have to look at the data, make sure everything is correct, also coordinate with the producers of the data as well as other downstream consumers to make sure that they are reading the new data and from the right place. I think in terms of timeline, once we migrated from V1 to V2, like thinking of implementation and like rollout, it was around 6 months end to end. I think for our third rollout now, I'm gonna say we're like nearing a year now. I think it was about 6 to 8 months of implementation, and then we're just working on the rollout now. Do you wanna add anything, Bora?
Yeah, I can maybe add a bit more about rollout. And since we have hundreds of events and now teams are basically owners of these events themselves, it's gonna take some time for them to essentially move on to the new system, and it takes time to onboard them as well. So it's like a bit longer than I would say implementation phase.
Yeah, thank you. So I have also one more question. You mentioned that, first I will ask like this, do you have also like if a user wants to book a new tour guide somewhere, you probably use a recommender system also, yes?
Yeah.
Okay. So I was wondering which of these events that you kind of enriched recently like you went from 50 something to 250, which of these new events are useful as the features for this recommender system?
For this recommendation system?
Yeah.
Yeah, so I think like these events, they power many different use cases. Like one of them being the recommendation, which is actually handled by a different team. But I think what they look at the most, they want to see the click-through rate of the tours. And they actually use that to see which tours have, like better conversion rate, but also tend to work well with different profiles of users. So I think they look at the page request, but they also look at like bookings as well for specific tours. We do also power two other very big use cases internally. One of them is our marketing attribution. So every time you land on GetYourGuide, we fire this event called attribution tracking, which has important marketing information such as campaign, like the referral where you're coming from. And we use that to like bid more efficiently, unlike Google and so on. And we also use all of these events to power our experimentation platform. So we have built also in-house like an A/B experiments platform, and we use these events to understand, which variations are working best.
Okay, I see. Thank you. But how then did you use these events afterwards? These new events that you got from the changing your architecture, basically.
How are we using them right now, you mean?
Mm-hmm.
Yeah, I think like with these two use cases that I mentioned, I think they're the primary consumers of this. And also we provide a lot of data for the data science team where they use like the recommendation.
Okay.
Yeah.
So we have another question from Andrew. How is anomaly detection done at the moment, and what are the options you are considering for automating this?
I could take this maybe. Currently, for the new pipeline, we don't have automated anomaly detections. We have for some previous iteration. We basically have some basic like number checks, count checks as well. And also like maybe Thiago, could you give more examples on that?
Yeah, so one thing that we're actually using for some of the events already, we have this tool called Anodot, which is it's a commercial tool. So it offers anomaly detection for essentially everything. You can just pipe your data to it, and then you can set up alerts and monitors directly on their UI. And then they can alert, like over Slack or send an email or through PagerDuty. So we do have some kind of like very basic high level anomaly detection, such as Bora mentioned, like row count by platform or by domain. But we want to further expand on this moving forward. We want to make this anomaly detection more real time. Today, it's like an hourly process that does that. And we also want to have more granular data for the anomalies.
We might also in the future check for more semantic validations as well. For example, maybe we could use something like Great Expectations to basically have some quality checks on our data. But this is like a topic that's probably we have to tackle very soon. Yeah, so currently no plans for that now.
Thank you. I would like to remind everybody that the session will close in roughly 4 minutes, so we have time for some final questions. If not, maybe I go and ask something else. You mentioned that with the Thrift, you kind of could get the better data out, yes? Maybe could you please elaborate more on that? Like, how does this work?
Do you want to do it more? Or?
You can take it, yeah.
Yeah, okay. So yeah, before essentially when we had ping, we just had the raw payloads, like JSON payloads being sent to the API, and that was never valid data. So it was just written directly to the data lake. And then when we wanted to read this data, we would find all these inconsistencies. But with Thrift, you can essentially define a schema, right? So Thrift is like a serialization format that you can use, and you can define a strong schema. So you can say visitor ID must be a string, like customer ID must be an integer, and so on. So we're able to actually validate this data directly when it's being produced. And with that, we ensure that only correct data is sent downstream. So when we want to analyze it, we don't really have like any surprises, like the data is guaranteed to be correct.
Okay. Thank you. Good. Then I would like to thank everybody for being here, and especially for I would like to thank Thiago and Bora for the interesting talk. If you have further questions, please go ahead and reach Thiago and Bora. And also, again, I would like to remind you about the datalift summit that is in summer. The link is already there. If you would like, please go ahead and register. So yeah, thanks, and thanks for the nice questions and the nice discussions. Have a nice weekend and also rest of the day today.
Thanks, everyone.
Thanks, everyone.
Bye-bye.
Bye.
Bye.